Hello, everyone. How are you doing? I trust you're all doing great. James from JTS Maths Tutoring here. Today, I'm going to be looking at solving matrix equations. And I've borrowed a question from Unisa Linear Algebra I, Assignment 2, 2024, question 1.2. So what I'm just going to give you guys is just a marking guideline. That is not all there is to it. There are plenty plus ways in which you can actually answer this question. But before we actually delve into the question itself, let me just quickly give you one or two laws concerning matrix inverses as well as transposes. Then we come back to the question. Okay, cool. So, right. Guys, I want you to know and understand that, okay, let me start with the simple matrix equation that most of us are very much familiar with. If I have AX is equals to B, right, where A is a coefficient matrix and where X is actually a matrix of unknowns and B is just a column matrix of the results, right? This is what we're actually going to use to solve equations, systems of equations. Okay, beautiful. Right. So literally, guys, let me take you back to high school. I want you to see it from that angle. It's like literally saying, can you make X the subject of the formula? But how do I go about it? Because we cannot divide matrices. So I can't just say, let's divide both sides by A, then X is going to be B over A. That's not how it works. So when it comes to matrices. So this is where you need to play with the property of the inverse of a matrix. All right. So if I multiply, so this is exactly what I'm going to do here right now. Okay. Right. And I want you to see order is very important when it comes to matrix multiplication, since matrix multiplication is not commutative in general. All right. So you can see I've got this on my left-hand side of A. I'm also going to have it on my left-hand side of B on this other side. Because remember that this is an equation. So whatever you do on the left-hand side, that's exactly what you're going to do on the right-hand side. Okay, beautiful. So having established this, you need to know and understand now that when you multiply a matrix with its inverse, or when you multiply the inverse of a matrix with a matrix, you get what we call an identity matrix. Remember, in real arithmetic, we've got our special number 1, right? If you multiply any number by 1, or you multiply 1 by any number, you're just going to get 1, right? So the same applies to matrix algebra. We have this special type of matrix which plays the same role that one plays in real arithmetic, which is called what? An identity matrix. So if you multiply what we have here right now, this is going to give me what? All right. So we've already established that this identity matrix, it acts as a 1. So it assumes that very same role that 1 does in the real arithmetic. So this means that when you multiply a matrix by an identity matrix, you are just going to get that very same matrix. So I have exactly what I want on my left-hand side. I now have my X. So I've actually solved for my X. All right. You definitely need this as we are going to be answering that question. So, okay, I'm going to take this one away. Fair and fine. Another thing that you need to know when you're dealing with the inverse of a matrix is that when you take the inverse of an inverse, you're going to arrive at the original matrix, right? Okay, then let me quickly look at the transpose of a matrix. We all know what a transpose of a matrix is. It's just a matter of rearranging the rows and the columns. So the inverse, the transpose of A, which is denoted by AT, where the T is sort of like that index or the power, is simply what were the rows in A becomes the columns and vice versa. That much I'd like to believe you know. All right, so if you take the transpose of a transpose, if you take the transpose of a transpose, just like taking the inverse of an inverse, you will arrive at the original matrix. All right, beautiful. Take note of that. If you have this, right, this is what you're going to have. Right, take note of that. Right, these laws, we need them. This is what we are going to use to manipulate what we're going to be looking at here right now. So that's why I'm taking my sweet time to actually go through this with you. Right. There's actually no problem having that small t, but I prefer the big T. That's why you see I keep on removing it. All right. Another thing which you also need to know and understand is when you have a product and you take the transpose of that product, you are going to get the product of the individual matrices, but in reverse order. Take note of that. This is the same thing when you are dealing with the inverses. So when you take a product, the inverse of a product is going to be equal to the product of the individual inverses, but in the reverse order as well. Right. Another thing which you need to know here is this. When you take the inverse of a transpose, is just as good as taking the transpose of that inverse. All right, so these are laws which you need to know. So as I'm going to be answering these questions, I want you to understand that whatever we are doing here, we are not thumb sucking information, but we are actually manipulating some known laws or rules or theorems, whatever you might want to put. Right, beautiful. Let's establish this. This is not all there is to it, but this is gonna be enough for us to be able to. Okay. Maybe before then, I want you to understand that if you take the transpose, of an identity matrix, you are just going to arrive at that identity matrix. All right. So having established this, let's actually go back and answer the question. My sincere apologies that I really had to take so much time to actually establish this. All right. Did I actually ask you for forgiveness? No, there's no need for me to do so because this is exactly what you need to know. All right, beautiful. So look at this. This is our given matrix equation and they want us to solve for x. Right, so what I'm going to do first here, I'm going to subtract b from both sides. And as soon as I've subtracted b from both sides, I'm going to take the transpose from both sides, on both sides, okay? Beautiful. So quickly with this, obviously this is going to be b transpose here, and the transpose of a transpose is going to be a. So done and dusted here. Then here we are taking the transpose of a transpose. What it means is that all this that is inside, that is what is going to be left on the left-hand side. Beautiful. But remember, we want to solve for x. It means I needed to do away with this b. I needed to do away with this a. I have to multiply both sides by b inverse and a inverse. Because remember, if I multiply this by its inverse, it's going to give me an identity matrix. The same applies to here. So remember, this is an equation. Whatever you do on the left-hand side, that's exactly what you're going to do on the right-hand side. Beautiful. In the very same order. All right. So this is what you see me doing right here. This is what you see me doing right here, which is exactly what you see on my right-hand side. Beautiful. Once you do that, remember this is going to be an identity matrix. This is going to be an identity matrix, and multiplying a matrix with an identity matrix is just going to give you the very same matrix, which is boom, where we are here right now. Okay, beautiful. I have not tampered with my right-hand side right now. Okay, let's get going. The next thing I said is simplify the left-hand side. So this left-hand side, which I have right here, this can actually be simplified. So remember, the transpose of an identity matrix is just going to be that identity matrix. Then the transpose of a transpose is going to give us the original matrix. So I have said yes, simplify the left and add I on both sides, meaning that the moment I do so, this I disappears from here and I've added it to this side. So I've got x is equals to what? Boom. I have successfully solved it for my action. All right, I do have alternative solutions. So let's have a quick look at this. Right, subtract b on both sides. You see what I did this time around? I've subtracted b on both sides, but I did not take the transpose. And I've simplified my left-hand side. I've taken advantage of the product of the transpose this time around. So I want you to see, I've subtracted b, which is here. Now, remember, when you are dealing with a product and you take a transpose of a product, it's going to be the product of those individual matrices, but in reverse order. This is why you see now I've got AT starting here. And remember, this one here, if you take the transpose of a transpose, you're going to get this matrix right here. Okay, beautiful. Transpose right here. Beautiful. And now, remember, what I want on the left-hand side is this part here. So I have to multiply with the inverse of this transpose here, which is exactly what you see me doing here. This is what is going to give me an identity matrix. This is what is going to give me what? An identity matrix. And remember, whatever I do on the left-hand side is exactly what I'm going to do on the right-hand side. So an identity matrix here, an identity matrix here, boom, it gives me exactly what I'm looking for right here, okay? And this is what I have here, okay? Obviously, this is going to give me, okay. What is going on here? What did I do right here? What did I do here? Because this is going to give me what? This is going to give me an identity. No. Okay, cool. I have not distributed anything inside. Beautiful. So I'm still cool. All right. Then you see what I've done right here now is that what I did on this line here is that I left distributed and right distributed what I have right here. So if you multiply this with this, is going to give me an identity matrix. And then right distribution inside here, this is going to give me what? This. Okay, beautiful. That's exactly what I have here. And remember, you left distribute this inside here, you're going to get that one. You right distribute, you're right here. Beautiful. Awesome stuff. And what I did now was to add I on both sides, which is what I've done. But remember, guys, they are not asking us to solve for the transpose of x. They are actually asking us to solve for x. So I ended up taking the transpose on both sides again. So you see now, what you see right here is that I've actually simplified this entire expression. The transpose of this is just going to be I right here, okay? So I'll leave it for you to actually see what I did to actually what? Simplify this, which at the end of the day, you can see it's exactly what I have right here. Okay, alternative solution 3. I took advantage of simplifying this inner expression first here before doing anything. I know that this is what it is going to give me this, right? Because remember, the transpose of an identity matrix is an identity matrix, and the transpose of this transpose is going to give me whatever, the original matrix. Beautiful. Now, for me to remove this B here and this A here, which is what we have right here, you multiply by what? By the inverse of B and on both sides, right? Beautiful. So you can actually see we'll end up with what we had earlier on. So I'll leave it for you to take over from here. All right. Okay, cool. I was really excited and I could have gone on and on looking for all these alternative ways of doing the very same things, just knowing how to go about manipulating this. So I'm going to leave it for you to actually look for that alternative solution here. All right, guys, this is what I had for you today. Till we meet again, be rest assured at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Allow me at this point in time to do what Mama taught me. Mamas always tell me a good visitor knows when to leave, or she would say, a good dancer knows when to leave the dance floor. So please like, comment, share, and if you have any other questions that you would want me to look at and explain them to you, feel free to let me know in the comment section. Adios, amigas and amigos.